Today we will discuss rational exponents. We are on page 4 in our notebook. The title will be Rational Exponents. The first thing you have is a little half sheet of paper that's going to go in your notebook. I actually trimmed it up a little bit so it fit neatly on the page. It shows you how to go from a rational exponent to a radical expression and vice versa. In your radical expression, the number above the radical sign is called your index. This here is actually your radical sign. The exponent that your variable is being raised to, or your number is being raised to, is simply called the exponent. And then the number that is the biggest one, it's the thing that's being raised to a power and underneath the radical, is actually called the radicand. That's the technical term. You will more commonly hear me refer to this as the base. That's your base number. That's where everything starts. Now, if you look at this worksheet, you'll see that they have very nice and neatly for you solved two examples. The rule that you need for step 1 is exponent over index. And what that means is you take what they gave you and you'll write it as a number raised to a fraction, and that fraction will be in the form exponent over index, which you can see here. It's very hard to see. Let me zoom in a little bit. So I have the 4th root of 5 to the 8th power. When I write that in a form that I can solve it, I'll write that as 5 raised to the 8 over 4. This is your exponent, and this is your index. So it's always exponent over index. So the number in front of the radical sign goes on bottom, and the number that the power that the number is being raised to goes on top. Now, 8 divided by 4 is simply 2, so we can simplify that fraction. And then I have 5 raised to the 2nd power, which is 5 squared, which is 25. And as you know, I expect you to box your answers. Notice they are working down the page. We will always work down the page. So they have one more example for you, which is the cubed root of 4 to the 6th power. Same thing. I'm going to write the exponent over the index. 6 divided by 3, and that gives me 2 as well, which we can simplify to 16. So now let's do some examples on the next page. On page 5, this is rational exponents continued. And we're going to start with example 1. Example 1 is the square root of 5 raised to the 4th power. Square root of 5 raised to the 4th power. Now, if they just give you a square root, it is implied. Oops, I apologize. I didn't really see that. It's all fuzzy. If they just give you a square root, the power, the number right here, will always be a 2. So my index equals 2. My exponent is 4. So when I rewrite this, I will write this as 5 raised to the power of 4 over 2. And that simplifies to 5 squared, which is 25. Let's do another one that's very similar to that. I have the cubed root of x raised to the 9th power. Same process. My index is 3. My exponent is 9. So I'll write it as my base raised to the power of the exponent divided by the index. Oops, my base is not 5. Let's try that again. My base is x. So I get x raised to the 3rd power, and since I cannot simplify that anymore, I'm done. It's okay to have variable answers. Okay, let's do another example. Example 3. They give me the square root of 2x to the 8th power. Well, this is the same thing as saying the base 2x, and I know it's the base because it's in parentheses, raised to the power of exponent over index. And since they didn't tell me what it was, there's no number in front, that's always a 2 for a square root. This simplifies, this 8 over 2, that simplifies to 4. So I have the base 2x raised to the power of 4. And if you remember our exponent rules, I can split this out as 2 raised to the 4th power and x raised to the 4th power. Oops. 2 raised to the 4th power is the same thing as saying 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16. And x to the 4th power, I cannot simplify other than saying it's x to the 4th power. Let's do another one. Example 4. They give me the 4th root of 16 x raised to the 3rd power. Now, 16 and x cubed are 2 separate terms. They're not in parentheses, so I can write this separately. This is the 4th root of 16 and the 4th root of x cubed. It's like they're being multiplied together. Well, the 4th root of 16, I have to think of a number that I can multiply times itself again, and times itself again. That'll give me 16. Now I use 16 because if you look over here, 2 to the 4th power is 16. So I can rewrite that. The 4th root is the root of 2 to the 4th power. I'm going to carry down what I didn't change. Now I can write both of these with rational exponents. This one, the base is 2, and I have exponent over index. Over here, the base is x, and I have exponent, which is 3, over index, which is 4. This one I can simplify. 4 divided by 4 is 1. 2 raised to the 1st power is just 2. But here I have x raised to the 3/4 power. There's nothing I can do with that, so I'll leave it like that, x to the 3/4. And we'll leave it in rational exponent form for this example. Let's do one more example and then we can be done. Let's do a really hard one. Example 5. I have the cubed root of 27 x to the 9th plus the square root, which I guess we don't need to show the 2. You should always be able to imply 2 from that, of 18, nope, not 18, 16. X raised to the 18th power not 18th, 6th power. Apparently I can't do math today. Minus the 4th root of 81 x raised to the 12th power. going to start over here with this one. This is like saying the cubed root of 27 and the cubed root of x to the 9th power. Then I have the square root of 16 and the square root of x to the 6th minus the 4th root of 81 and the 4th root of x to the 12th. This is the same thing. 27 is like saying 3 times 3 times 3. So I have the cubed root of 3 cubed. Everything else didn't change on that side. Then over here I have the square root of 16. Well, that's the same thing as saying 4 squared. Then the 4th root of 81, that's like saying 3 to the 4th power, because 3 times 3 is 9, times 3 is 27, times 3 again is 81. So here I get 3 raised to the exponent over index times x raised to exponent over index plus 4 raised to exponent over index times x raised to exponent over index minus 3 raised to exponent over index and x raised to exponent over index. And then we'll simplify. Oh, you can't see that. 3 over 3 is 1. So 3 raised to the first power is 3. X raised to the 9 over 3. Well, 9 divided by 3 is 3, so that's x cubed. Plus 2 over 2 is 1, so 4 raised to the first power is 4. X raised to the 6 over 2. Well, 6 divided by 2 is 3, so that's x cubed. Minus, again, I have a 1, so I get 3. And 12 over 4 is 3, so I have x cubed. Well, these are all like terms, so I can combine my like terms. 3x plus 4x is 7x, x cubed, minus 3x cubed. Then these two are also like terms, and 7 minus 3 is 4x cubed. And that concludes our notes for today. Do not forget to glue in your half sheet on the left-hand side of your notebook. And then the last thing you need to do is add the title on page 4, Rational Exponents, to your table of contents.